Definition. Two events E and F are independent if the probability of E given F equals the probability of E, or equivalently, if the probability of F given E equals the probability of F. So this is one way that we can determine whether two events are independent. So like the examples we've seen so far, logic tells us whether or not the two events are independent. But if it's not obvious whether two events are independent or not, we can check whether they are by looking at this probability. So again, if I find the probability of E given F, and if that's the same as probability of E in the first place, or if I find the probability of F given E and that's the same as probability of F in the first place, then that would mean that the two events are independent. But if these things don't equal each other, then E and F are not independent. Quick example. The following data represent political party by age from a random sample of registered Iowa voters. Use the data to answer the following question. So we have information about the numbers of Republicans and the number of Democrats, and then we also have by age, 17 to 29, 30 to 44, and so on. Find the probability that a randomly selected Iowa voter is Republican. So we're going to do the probability of Republican. No conditions or anything like that, just the probability of being Republican. Well, there are 2,200 Republicans out of 4,000, so that would be 2,200 out of 4,000. And 2,200 divided by 4,000, that would be 0.55. Now that divided evenly, so I'm putting an equals, not an approximately equals there. Not that it really matters that much, but there is a distinction. B, find the probability that a randomly selected Iowa voter is Republican, given that he or she is 30 to 44. So now we have a conditional probability. What's the probability of being a Republican, given that they're 30 to 44 years old? So the fact that I know they're 30 to 44 years old tells me I'm only looking at this column. I know that's a given. Now, out of that given, out of that group, there are 340 Republicans out of 724. So this probability would be 340 out of 724. So 340 divided by 724, that is 0.4696. Approximately. So 0.4696. So this right here tells me that the event being a Republican and the event being 30 to 44 are not independent. They are dependent because the probability changed. So the probability of E is not the same as the probability of E given F. Therefore, E and F are not independent. That's what we're talking about here. So there is a dependence apparently between age and whether they're a Republican or not. Find the probability that a randomly selected Iowa voter is 30 to 44. So again, no condition on this. We're just looking for the probability of being 30 to 44. Well, there's 724 individuals that are 30 to 44 out of 4,000. So if I take 724 and divide by 4,000, that would be 0.181. Find the probability that a randomly selected Iowa voter is 30 to 44, given that they're a Republican. Now notice that question D is different from question B. In question B, the question was, what's the probability that the individuals are Republican given they're 30 to 44? Here, what's the probability of the 30 to 44 given that they're a Republican? There's a difference. So the probability of 30 to 44 given that they're a Republican, again, is not the same here. If I'm given they're a Republican, then I know I'm only looking at these 2,200 individuals. of those 2,200 individuals, 340 are 30 to 44. So that's going to be 340 out of 2,200. Or 340 divided by 2,200, that is 0.1545 if I round to 4 places. So again, the age 30 to 44 and being Republican is not independent, because the probability of being 30 to 44 and the probability of being 30 to 44 given that they're Republican aren't the same probabilities. So are the events Republican and 30 to 44 independent? No. Why not? Because of two reasons, really. Because the probability of being Republican does not equal the probability of being Republican given that you're 30 to 44. And also, the probability of being 30 to 44 does not equal the probability of being 30 to 44 given Republican. So for either one of these reasons, you don't really have to do both, but for either one of these reasons, Republican and 30 to 44 are not independent. Are the events Democrat and 65 plus independent? Well, the way to tell is I could find the probability of being a Democrat. I can find the probability of being a Democrat given that 65 plus and see if those are the same probability. Or I could find the probability of being 65 plus, and I could find the probability of being 65 plus given that it's a Democrat, and I could compare those. I don't really have to do both, but I can do either one of these comparisons. So the probability of being a Democrat would be 1,800 out of 4,000. 1,800 divided by 4,000, that is 0.45. The probability of being a Democrat given 65 plus, I'm only looking at this group. So I'm given that there's 65 plus, so there's 1,020 in that group, and 459 of them are Democrats. So the probability would be 459 out of 1,020. Now, if I take 459 and divide by 1,020, that is also 0.45. The fact that these are the same tells me, yes, the event being a Democrat and being 65 plus are independent because the probability didn't change. And if I did these, the same would work out there. Are the events Democrat and 65 plus mutually exclusive? So again, the point here is don't confuse independence with mutually exclusive or disjoint. So Democrat and 65 plus are not mutually exclusive because there are 459 individuals who are both. So the answer here is no. And why? Because there are 459 people who are both. I didn't have that so you could see. No, because there are 459 people who are both Democrat and 65 plus.